Hi all, very good morning. Welcome to Chandan Likes English YouTube channel. In this session, I am going to explain in detail about magnetism. Okay, this is from physics chapter. So each and every student from starting to ending, please listen carefully so that you can answer to the question which I am going to display at the end of the session. Okay. What is magnetism? What are the properties of magnetism? What are the types of magnet? Okay, and what are the uses of magnets? What is magnetic strength? What is magnetic flux? What is magnetic moment? In this session we are going to discuss. So mainly in the exam point of view, which topics are going to be stressed? I am going to explain those topics only. So each and every student listen properly. Very good morning, Lakshman. Okay, so after the explanation of concept, I am going to display the MCQs related to those topics, and you must mention the answers in the comment section. Okay, very good morning, Arjun, Lakshman. Before starting the session, once all of you please click the like button so that this session will reach to maximum strength. Okay, so even after the completion of the live session, please share it to your friends and relatives who are preparing for SSC, RRB and other competitive exams also. Okay. Very good morning one and all. So let's start the session. What is magnet actually? So in general, we all know what is magnet. So what will be happening in the magnet? So what is happening in the magnet and what properties it will be exhibited? So we are going to discuss in this session. Okay. What is magnet, students? Wait a minute. Okay, a magnet is an object that it is able to attract or repel another magnet. So not only magnet, students, either it may be some magnetic metals like iron, copper. Okay, so copper does not exhibit a magnetic property when compared to iron. Okay, what is this magnet? So magnet, it will always attract some other magnet. Okay, and what is law of magnet? Actually everybody knows what is law of magnet. Like poles repel, unlike poles attract. So I think this is known to everyone. So what is that? What is the law of magnetism? Like poles repel and unlike poles attract each other. So everybody must know this. Okay, so what is magnet, students? Magnet is nothing but it is an object which is able to attract or repel another magnet. Okay, no, it has a magnetic field around it. This magnetic field gives the object its magnetic properties. So around the magnet, okay, around the magnet, that magnet has some magnetic field, and that magnetic field will give the properties to that particular magnet. Okay, did you understand what I said? Magnet is nothing but it is an object which is able to attract or repel some other magnet. Okay, the field which is surrounding that magnet is known as magnetic field, and that magnetic field will have the magnetic properties. Okay, in this session we are going to discuss in detail, students. So each and every students listen properly. Okay, next, what are the properties of magnet actually? Okay, this is also very important concept. What is the properties of magnet? Magnet have two opposite poles, as we all know. So magnet has two opposite poles. One is north pole and one is south pole. In magnet, okay, what unlike poles attract, like north and south poles attract, but like poles repel. That means there is no attraction between the like poles. That is one of the property of this magnet. Okay, magnets have two opposite poles, the north pole and the south pole. A pole is a region where the strength of the magnet is concentrated. So what happens actually in that pole? Okay, the magnet consists of two poles. One is north pole and one is south pole. So what happens at the pole? Okay, the magnetic properties, that means the strength of the magnetism will be concentrated at the poles. Okay, did you understand what I said? That means the strength of the magnet, where it is going to be concentrated, the strength of the magnet is going to be concentrated at the pole. Very important point to be noted. Next, a magnet has a magnetic field around it, as I told you just before. Okay, so the magnet, it consists of a magnetic field around it, and that magnetic field will give the properties to the particular magnet. Okay, this magnet consists of two poles, one is north pole and one is south pole, and the strength of the magnet will be concentrated at that poles only. Next property, magnets attract strongly only certain materials such as iron, steel, nickel and cobalt. So magnet will be attracted to only some of the metals only, like iron, cobalt, steel and nickel. Okay, and we are going to discuss about that topic also, what are the types of magnetic materials. Okay, so mostly magnet will be attracted to which type of like metal, students? Iron, cobalt, nickel and steel. Okay, very very important. Next, if a magnet is suspended so that it can swing in a horizontal plane, it comes to rest with the north seeking or north pole, always pointing towards the north south pole. So I will explain you this point. Okay, for example, I am suspending the magnet magnet. Okay, the magnet is freely suspended. I have tied the magnet through one stand with the help of thread. So what that magnet is taking place? Okay, which place that magnet is taking place means the magnet is taking place. So remember students, even our earth has some magnetic property. Okay, even our earth has some magnetic property. So our earth will be down towards us. Okay, that means our earth is south. Okay, so if a magnet is suspended freely, so what position it will take? So if a magnet is suspended freely, what position it will take? As our earth has magnetic properties, our earth will be in south position, right? So what I told you students, like unlike poles attract each other. So as when the magnet is suspended freely, so what position it will take, students? It will take the position towards the north. Okay, it will take position towards the north. Why? Because our earth lies in the south. Okay, as unlike poles attract each other, so earth is showing in the south position, like magnet will be placed in the north position. So this principle will also be applicable to the compass. Okay, this principle is applied to which type of instrument, students? Compass. In order to know the directions of anything, so what we will use in general? We will use compass, right? So how the directions will be shown? Why? Because to the help of magnet. Okay, that compass is also a small magnet, so it will be also having the north pole and the south pole. Okay, when the magnet is suspended freely, it will automatically show the north position to us. In that way, we will use the compass to show the direction. Okay, so this is what explained in this particular fourth property. Next, when the like poles of the magnets are brought near each other, repulsion occurs. So as I told you, like poles repulse. For example, okay, when the two magnets are placed south to south, then there is no magnetism between those two magnets. Why? Because unlike poles attract, like poles repel. Okay, this is the fifth property of magnet. Next, so this is magnet, students. This is the north pole and this is the south pole. As I told you, the strength of the magnet lies where? The strength of the magnet lies at the pole. Okay, the whole strength of the magnet lies where, students? At the poles. Either it may be a north pole or it may be a south pole. The field, the lines which are surrounded in a closed loop, the lines which are surrounded in a closed loop to the magnet are known as what? Magnetic lines, and that particular field is known as what? Magnetic field. Okay, and in upcoming slides we are going to discuss what is magnetic movement, what is magnetic flux, what are the types of magnetic materials, how many types of magnetisms we have, we are going to discuss. Okay, so did you understand what I said? So unlike poles attract, like poles repel, and the thing which is surrounded around the magnet is known as magnetic field, and the lines which are in a closed loop, that are known as magnetic lines. Okay, next. Very good morning. Once all of you click the like button, students. Next, types of magnetism. In general, we have 5 types of magnetism. Okay, diamagnetism, paramagnetism, ferromagnetism, ferrimagnetism, antiferrimagnetism. In detail, we are going to discuss each and everything. Okay, how the materials behave. So, what are the types of that materials? Either it may be a magnetic material or it may be a non-magnetic material. In this session, we are going to know that. Okay. The 5 main types of magnetism based on how materials respond to magnetic fields. If I place a object, so I don't know which object is that. Okay, how it is reacting. Okay, if I place an object near to the magnetic field, how it behaves. So according to that, I can decide whether it is a diamagnetic material or paramagnetic or ferrimagnetic or ferro, and the last thing is antiferrimagnetism. Okay, if I place an object so near to the magnetic field, so I can decide what type of magnetic material it is. Okay, as the experiments have done earlierly, so I am going to explain each and everything. So what are the 5 types of magnetism, students? Diamagnetism, paramagnetism, ferromagnetism, ferrimagnetism and antiferrimagnetism. Okay, so diamagnetism and paramagnetism, these 2 types of magnetisms exhibit very weak magnetism. Okay, these 2 are very weak. That means they do not have the attraction power when compared to another magnetisms. Okay, remember, very important, which are the 2 weak magnetism type, diamagnetism and paramagnetism. And the next thing, temporary effects, while the latter 3 exhibit stronger long range magnetic order with ferromagnetism like iron. So among all the 5, which magnetism exhibit most magnetic property means ferromagnetism. So what is the example for this ferromagnetic material means iron. You all know very well. So the magnet will be easily attracted to the iron, right? By this you can say that iron is a ferromagnetic material. That means it will be easily attracted to the magnet even it is somewhat far. Okay, did you understand what I said? There are 5 types of magnetism: diamagnetism, paramagnetism, ferrimagnetism, ferromagnetism, antiferrimagnetism. Among these 5, the first two like diamagnetism and paramagnetism, these 2 have the weak magnetic power. And when it comes to ferromagnetism, so this example of this ferromagnetic material is iron. So when compared to among all this, so it will be very strong. The power of the magnet will be very strong for this type of materials. Okay. Next. Now we are going to discuss each and everything in detail. First thing is like diamagnetism. As I told you already, diamagnetism and paramagnetism are weak. They are having the weak power, magnetic power. So let us discuss what are the examples for this type of magnetism. Diamagnetism. Okay, materials weakly repel magnetic fields. They have paired electrons and no net magnetic moment. So what is happening here? Okay, actually what I told you, students, when a magnet is suspended freely, so automatically it will point out towards the north. When a magnet is suspended freely, so automatically it will take the position of north. So it is also applicable. The same procedure is applicable to the compass also. In the similar way, so what is happening in the diamagnetism? What is happening means, so there is no magnetic moment. Okay, there is no magnetic moment in the magnet. So automatically what will be happening in that magnetism? Okay, there is no attraction between the magnets. For that purpose, we will say this diamagnetism is having very weak magnetic power. Okay. What are the examples? Examples are nothing but copper, gold and water. Okay. So observe, you take gold and keep it near like a magnet. So it will not be attracted as much as iron. Why? Because it is exhibiting the properties of diamagnetism. That means there is no magnetic movement between those two objects. Next thing, paramagnetism. What do you mean by paramagnetism? So this is also having very weak magnetic power. Okay, so what is the difference between diamagnetism and paramagnetism? Means in diamagnetism there is no magnetic movement at all. There is no like a strength, there is no orientation of magnet at all in diamagnetism. When comes to this paramagnetism, so it will have a randomly magnetic movement. Okay, even though it is having very weak magnetic power, sometimes it is also having a randomly magnetic movement. Okay, what are the examples for this? Aluminium, platinum, oxygen. Okay, both are same, but the difference of diamagnetism and paramagnetism means in diamagnetism there is no magnetic movement at all. When comes to paramagnetism, so randomly there appears magnetic movement. Okay, next ferromagnetism. The magnetism, okay, the materials which attract strongly towards the magnet are considered as what, students? Ferromagnetic materials or ferromagnetism. Okay, so what are the example? Iron, cobalt and nickel, very very important. Why? Because these ferromagnetisms, it is having a very strong magnetic movement. So what is this magnetic movement, students? So this is like a magnet. So this is what, students? Okay, this is iron. So this is the like what I am explaining, listen properly. So what I told, when a magnet is suspended freely, it will automatically take the position of north. Okay, this is a magnet and this is the iron. How this iron will be attracted to the magnet? Automatically it will take the position of the north and it will be attracted to this. Okay, so what is happening here? A movement is happening here. Magnetic movement is happening here. For ferromagnetism, there is a very strong magnetic movement. For that purpose, it is exhibiting the magnetic movement, magnetic power more. Okay. Next, ferrimagnetism. So the only difference between ferro and ferri is I. So what is that? We will see now. Similar to the ferromagnetic with the opposing magnetic moments that are unequal in strength. So what is this, students? Actually in ferromagnetism, the magnetic moment will be in same direction. Okay, in ferromagnetism, the magnetic moment of the magnet will be in same direction. Okay, when comes to ferrimagnetism, the direction will be opposite. The magnetic moment direction will be opposite. Okay. So what are the examples? Example is ferrites. What is the perfect example for ferrimagnetism? Ferrites. So when compared to ferromagnetism, ferrimagnetism is weaker. Why? Because the magnetic moment is taking place oppositely. Okay. Next, anti-ferrimagnetism. Magnetic moments align in opposite direction. Magnetic moments. Okay. So in ferrimagnetism, so some not completely it is not in magnetic moment, completely it is not in opposite direction. So randomly it is in opposite direction. When comes to ferrimagnetism, total complete movement is having like opposite direction. Okay. So what are the example for this anti-ferrimagnetism? Chromium. Okay. Next. Sankranti offers are going on. Today is the last date to avail is offers. Up to 60% offers are going on. Any course you can get it only for $499. Okay. So the classes will be available both in English as well as Telugu languages. SSC exam complete course is also available on our Chandan Law exam. Railway exams are also available on our Chandan Law exam. Up to 60% offers are going on. Today is the last date to grab the opportunity. Bank exams 2026 are also on offers. Bank SSC RRB combo courses also you can get it for offer, up to 60% offers. APPSC SI constable courses are also on offers. Zero to hero course. The people who are struggling to solve like arithmetic, reasoning and advanced maths in your exam within a short period of time. Okay, if you take this course, you can easily attempt any type of question. Okay. Next, what is magnet and what are non-magnetic materials? Okay, till now we have discussed what are the types of magnetism, what are the properties of the magnet, what is magnet actually, and now we are going to discuss what are magnetic materials and what are non-magnetic materials. So nothing but, everyone can say this. So magnetic materials are nothing but the materials which attract to the magnet. The materials which attract to the magnet are considered as magnetic material, and the materials which do not attract, that means which repels when we keep it near to the magnet. So those materials are said to be what, students? Non-magnetic materials. Okay. Magnetic materials are those that are strongly attracted by magnets. So non-magnetic ones are those that are not attracted by the magnets. What are the example? Okay, examples of magnetic substances are iron, steel, cobalt and nickel. While wood, glass and copper are example for non-magnetic materials. Okay, substances that are strongly attracted by magnets are, so which magnetic materials have strong magnetic effect means like iron, steel, nickel and cobalt. For this purpose, these materials are considered as what, students? Ferromagnetic materials. Very, very important. So among all the elements present in our universe, so which will have the most magnetic power? Iron, nickel, cobalt and steel. Okay. For this purpose, as they are strongly attracted to the magnet, so these are considered as ferromagnetic materials. Okay. Next. As I told you already, what is magnetic field, students? Magnetic field means the field which surrounds the magnet. Okay, the field which surrounds the magnet in a closed loop is said to be magnetic field, and the lines which forms a closed loop are considered as what, students? Magnetic lines. Okay, within this magnetic field only, that magnet will exhibit the magnetic properties. Remember, very, very important. So beyond this magnetic field, there will not be any magnetic properties to that particular object. Okay. Magnetic field is the space around a magnet where magnetic field is absorbed or experienced. This is nothing but what, students? Within this place only, this magnet will have the properties of the magnet. Beyond that, there will be no magnetic properties. Okay. The diagram below shows magnetic field lines around a bar magnet, and these are considered as what, students? These lines are considered as what? Magnetic fields. I think everybody know this. Okay. Next. Is it clear, students? Please, any one of you say yes. Are you on live or left? Is it clear? Are you understanding what I am discussing? Is it clear? Mention it in the comment section. Okay. Next thing. 5 key properties of magnets. So, again we are going to discuss more properties of magnets. Why? Because in magnetism, like physics concept, so mostly they will stress about these properties only. Okay. Next, they attract magnetic materials like iron always have north and south poles, like poles repel while. So what they are saying, students? Magnets always attract to the materials which are having the strong magnetic properties. As we all know, what is law of magnetism? Like poles repel, unlike poles attract. So when compared to all other materials, so which material has the most or strongest magnetic properties? Iron. Okay. Done, students. Magnets attract ferromagnetic materials, iron, nickel and cobalt. So some other properties we are going to discuss. What is polarity, what is attraction, what is magnetic field, what is pole strength. In this we are going to discuss. Okay, these are some of the properties of magnets. What is polarity? 2 poles. Every magnet has a north and a south pole. Pole always exists in pairs and cannot be isolated. No magnetic monopoles. What is this polarity, students? Listen. Okay, very, very important. Magnet always made up of 2 pairs. Magnet always has 2 pairs. It does not exist in a monopole. Okay, it will have north pole and south pole. Magnet always consists of pair of poles, and that property is known as what, students? Polarity. This magnet may not exist in monopolarity. So that is the property of magnet. And the next thing, attraction and repulsion. What do you mean by attraction and repulsion? Like poles always repulse. Repulse means they do not come together, and unlike poles attract to each other and they come together and make it join. Next, directive property. A freely suspended magnet will always align itself in the geographical north-south direction. I told you already. Okay, when we are suspending a magnet, freely, so which direction it will take automatically? It will take the direction of north-south direction. And this directive property is applicable to which type of instrument, students? Compass. Okay, that compass is a very small magnet. So when we are like freely suspending that compass, it will automatically take the north-south direction. Why? Because even our earth has some magnetic property. Okay, as unlike poles unlike poles attract. So when we are suspending freely, it is automatically taking the position of north-south direction. Okay. Next, what is magnetic field and what is pole strength? As I told you already, the field which is surrounded around the magnet is considered as magnetic field. And what is this pole strength, students? So most of the magnetic strength, so it will be concentrated at the poles. Okay, most of the magnetic strength, it will be concentrated at the poles, and that strength is known as what strength? Pole strength. Okay. Next, very good morning. Next, uses of magnets. You all know, I think everybody knows this. Okay, where we will use this magnet, students? Like used in making other magnets. In order to prepare other magnets, so we will use magnets, and it is used in loudspeaker, it is used in making coil meters, and it is also used in making telephone speakers. So these are some of the like very important uses of magnets. Okay, yes, very good Ajay. Okay, so magnets have the strong strength at the poles and weak strength at center. Very good. Okay. Next, what is magnetic moment? I told you already. What do you mean by magnetic moment, students? So actually, when I place the magnet here, and if I place the object there, this is iron. So automatically this this iron object is having some orientation, right? And this orientation and strength both are considered as what, students? Magnetic moment. Okay. A magnetic moment or magnetic dipole moment is a vector quantity. What do you mean by vector quantity, students? What do you mean by scalar quantity and what do you mean by vector quantity? Scalar quantity means which is having only the magnitude. Okay, which is having the only magnitude is considered as scalar quantity. What do you mean by vector quantity? Which is having both the direction and magnitude. So that quantity is known as what? Vector quantity. And this magnetic moment, it is having both magnitude and direction. Okay, magnetic moment, it is having both the magnitude as well as the orientation, direction. Next, that measures an object's magnetic strength and orientation, indicating its tendency to align with an external magnetic field. So nothing but what is magnetic moment? Just remember this example. So this is a magnet and this is a iron material, ferromagnetic material. So when we keep these two materials closer, so what happens, students? So these, okay, due to the magnetic field strength, so due to the magnetic field strength, what this iron is going to be, it is going to align with the magnet. So what is happening here? The orientation of the object is happening here due to the strength of the magnet. Okay, due to the strength of the magnetism, the orientation of the iron object is going to be aligned with this magnet. So that is considered as magnetic moment. Okay, next. So how you will, what are the units of this magnetic moment? This is very important. What is the SI unit of magnetic moment? Ampere square meter. Okay, ampere square meter is the unit of this magnetic moment. This is very important. Okay, in every topic in the physics point of view, you must know what is the unit of that particular property. Okay, for magnetic property, magnetic moment. What is the SI unit of magnetic moment? Ampere square meter. Okay. Next, or joules per Tesla, or joules per Tesla. These are the two units of magnetic moment. Yes, very good, very good. Next, magnetic shielding. What do you mean by magnetic shielding? Okay, so when you look at these two, okay, so this is active but unprotected. This shielding is active but unprotected. When comes to the second, magnetic shielding, it is active and protected. Okay, in this manner the magnet should be shielded. The magnet should be shielded in this manner so that it will be active and protected. If we shield the magnet in this manner, so it will be active and unprotected. Shielding is nothing but what, students? So we have to shield the magnet with the magnetic material itself. For example, if we shield the magnet with plastic, does the magnet will have the properties of the magnetism? No, that means it is active but unprotective. Okay. It is a protection against the magnetic waves which allows to attenuate in a defined volume the ambient magnetic field. How to make a magnetic field? By using a material capable of concentrating the magnetic field. Did you understand what I said? The material which is having the magnetic properties, that material we have to use for this magnetic shielding. If we use the plastic material for the magnetic shielding, so there will be no protection for that particular magnet. So that is considered as what, students? Magnetic shielding. Even the magnetic shielding should be done with magnetic material itself. That's what they are saying. Okay. If we use the magnetic material for shielding, so that shielding will be active and protected. Okay. Very good, very good. Magnetic field Tesla, magnetic dipole moment or magnetic moment Ampere square meter. Very good, Ajay. Okay. What is magnetic flux? So you leave this this definition, students. Look at this diagram. Okay. So what is this? This is having the maximum flux. That means, so actually this is the area. This is a cross sectional area. The magnetic lines, okay, the magnetic lines when compared to this diagram and this diagram, the magnetic lines are passing more in this diagram and less in that diagram. That means if there are no magnetic lines passing through a cross section, that is having the maximum flux. If there is having a less magnetic lines passing through the cross section, that surface is having the less magnetic flux. Okay, and this magnetic flux, it is denoted by what, students? Like Weber. What are the units of this magnetic flux? Weber. Weber is denoted by like this. Okay, very, very important. So from this we have discussed two units. What is the SI unit of a magnetic field? Okay, Tesla, and magnetic moment Ampere square meter, and what is the SI unit of magnetic flux? Weber. Very, very important, students. Okay, mostly questions will be from this only. Next, did you understand now what is this, students? The magnetic field, the magnetic lines in cross sectional A is more when compared to the magnetic lines which are passing through the cross section B. By this we can say that there is a maximum magnetic flux in cross section A when compared to cross section B. Okay, what do you mean by magnetic flux actually? Now we are going to discuss. It is a measure of the amount of magnetic field passing through a given surface. Okay, the number of magnetic lines passing through a given surface is considered as magnetic flux. If there are more number of magnetic lines passing through a surface, that is having the maximum flux. If there are less number of magnetic lines passing through the surface, and that is having the minimum magnetic flux. Okay, magnetic flux. What is the SI unit of magnetic flux? Weber. Very, very important, students. Very good, Ajay. So not only Ajay, even each and every student can mention your answer. Okay. If you know the additional information regarding this magnetism unit, you can also mention them in the comment section. Next. Yeah, questions. Which of the following best defines a magnet? An object that attracts only iron, an object that can attract or repel another magnet, an object with electric charge, an object that produces heat. So each and every students, I have explained the topic. So what topics I have explained, students? The topics which will be appeared in your examination, I have stressed on those topics only. Okay. Now I am going to display the questions which are related to those topics and even the questions from PYQs. Okay. Very good, students. So magnet is not only like it is having not only the attracting property, but that magnet sometimes it is also having the repulsion. If we place the two like poles together, so they exhibit a repulsion property. Next, the region where the strength of the magnet is concentrated is called magnetic axis, magnetic domain, magnetic pole, magnetic field. Everybody mention your answers in the comment section. I have already explained you. So, like the strength of the magnet is concentrated at what part of the magnet? So tell me, students, the strength of the magnet is concentrated mostly at what part, at which part of the magnet? At poles. Okay. So strongest at the pole and weakest at the center. A magnet always have only one pole, two similar poles, two opposite poles, multiple random poles. So what this magnet will exhibit? Magnet always exhibit dipolarity. Okay, polarity. What do you mean by polarity? It will have only one pole, or it will have the two similar poles, or it will have the two opposite poles. So what is the answer for this question? Very good. It will be having two opposite poles. One is north and one is south. Which property allows a magnet to be used as a compass? Attraction property, directive property, repulsion property, heating effect. I have already explained you. Okay. So which property? That property is known as what? Okay. Even I have explained you the like examples also. When a freely suspended magnet, when a magnet is suspended freely, so what happens to that magnet, students? It will automatically take the position of north-south direction. Yes, directive property. When two north poles of magnet are brought close, what happens? Attraction, neutralization, repulsion, magnetization. Very good, students. So if you know the concept, you can attempt any type of questions. Either it may be assertion reason, or it may be like a statement wise question, or it may be a match the following. So nowadays mostly they are stressing on match the following. So what are the units? Okay. If you know the concept, you can attempt any type of questions. Okay. So instead of reading all the concepts, if you stress on those topics which are going to be repeated in exams, that is enough. Okay. What is the answer, student? Very good. Repulsion. Why? Because like poles repel, unlike poles attract. Very good, very good. The law of magnetism states that all poles attract, like poles repel, and unlike poles attract. Magnets lose strength with time. Very good, Ajay, very good. Very good, Sharma, very good, Joseph. Okay. So not only this magnetism chapter, students, even I have explained many general science topics. Okay, you can go through that sessions. Okay. Very good. Which of the following is a ferromagnetic material? Copper, glass, iron, wood. So I have already told you. So among all the magnetism, which is having the strongest magnetic strength? Ferromagnetism or ferromagnetic materials. So among all the four options, which material is exhibiting ferromagnetic properties? Tell me, students, when it comes to copper, glass, wood. So copper, it is having diamagnetism. Copper is the example for diamagnetism. Glass, wood. So these are considered as non-magnetic properties, non-magnetic materials. Very good. Iron. Which type of magnetism is shown by copper? Ferromagnetism, paramagnetism, diamagnetism, ferrimagnetism. So tell me, students, what is the answer for this question? Very good, very good, very good. So aluminium is not a ferromagnetic material. Lakshman. Aluminium is not a ferromagnetic material. Diamagnetic. What is the answer for this question? Which type of copper is having? Very good. Copper is having diamagnetism. Okay. Aluminium is having paramagnetism. Yes. Paramagnetic materials are strongly repelled by magnetic fields, are weakly attracted and lose magnetism when field is removed, become permanent magnets, have no response to magnetic field. So tell me students, I have told you already, diamagnetism and paramagnetism. Okay, these two are having weaker magnetic strength. Why? Because okay, in diamagnetism, okay, there is no presence of magnetic moment. So when it comes to paramagnetism, there will be randomly magnetic moment occurs. Okay? Yes. And what is the answer for this question, students? Option B. Which material shows antiferromagnetism? Iron, nickel, chromium, cobalt. I have already explained you what is antiferromagnetism. Antiferromagnetism means, okay, the magnetic moment takes place oppositely. Okay, the magnetic moment takes place oppositely. What do you mean by oppositely, students? So this is magnet and this is object. So the magnetic moment, it is not aligning and it is not attaching to the magnet. So how it is behaving means, it is behaving like this, like this. So it is behaving like opposite direction. That means it is not exhibiting any magnetic properties. Why? Because the magnetic moment of these anti-magnetism is like it is having the movement oppositely. Okay. So what is the answer, students? Chromium. Ferrimagnetic materials differ from ferromagnetic materials because they have no magnetic domains, have equal and opposite magnetic moments, have unequal opposing magnetic moments, or non-magnetism. I have already explained you ferromagnetism and ferrimagnetism. Both are same, but only difference is. So you have to mention the answer in the comment section. Tell me. No, students, listen, read the question properly. Okay, read the question properly. So they have mentioned ferrimagnetic materials differ from ferromagnetic materials. So now we have to say about the ferrimagnetic. Why? Because ferrimagnetic is in the first place. Very good, Lakshman. 3 is the correct answer. Have unlike opposing magnetic moments. Okay, I have already explained you ferromagnetism. So when compared to all the magnetism, these ferromagnetism have strongest magnetic field. Ferromagnetism and ferrimagnetism both are same, but the difference is, okay, so some of the magnetic moment in ferrimagnetism, so the moment of the magnetic poles at sometimes, so it will be unequal. Okay. Which statement about magnetic field is correct? It exists only inside a magnet, it is visible to eye, it is strongest at the poles, it does not affect space around a magnet. Tell me the correct statement of this. Very good. Okay, it is strongest at the pole. Magnetic field lines around a bar magnet start and end at the same pole, or straight lines form closed loops, exist only outside the magnet. So tell me what is the correct option regarding this magnetic field. Okay, I have already told you what is this magnetic field, students. Magnetic field is nothing but the field which is surrounded around the magnet. So beyond that field, there is no magnetic property. There will be no magnetic properties. Okay, very good. Which of the following is non-magnetic substance? Steel, nickel, cobalt, wood. Okay, I have already explained what do you mean by magnetic materials and what do you mean by non-magnetic materials. Magnetic materials are nothing but the materials which are strongly attracted to the magnet. Example, iron, okay, cobalt, nickel and steel. And the materials which does not attract to the magnets are considered as non-magnetic materials. And the example is wood, plastic, water, etc. A freely suspended magnet aligns itself along east-west direction, north-south direction, any random direction, vertical direction. So, I have already explained these one also. So, if I suspend a magnet freely, so automatically it will take which direction? Okay, it is asking that question, and that property is also known as directive property. Very good. North-south direction. Which of the following is not a use of magnet? Loudspeaker, moving coil meters, electric heaters, telephone speakers. We will use the magnet in loudspeakers, telephone speakers, or even in to prepare another magnet, but it is not used where? Electric heaters. The SI unit of magnetic moment is Tesla, Weber, ampere square meter, Newton per meter. What is the SI unit of magnetic moment? Magnetic moment is a vector quantity. That means it is having both magnitude and direction. Okay. What do you mean by these, students? Nothing but due to the strength of the magnet, okay, due to the strength of the magnet, the object is aligning. It is taking some orientation to get aligned to the magnet. That is known as magnetic moment, and its unit is ampere square meter. Magnetic moment indicates electric resistance, magnetic strength and orientation, thermal energy, gravitational force. Just now I have discussed. So, actually what do you mean by magnetic moment? Even I have explained you with the example. So, this is like a magnet and this is the magnetic object. Okay, this is an object. If it is exhibiting the magnetic properties, so directly it will attach it to this magnet. That means due to the presence of the magnetic strength, this object will be oriented and it will be attached to this magnet. That is considered as magnetic moment. Magnetic shielding is achieved by using plastic materials, blocking electric current, concentrating magnetic field lines, increasing magnetic flux. Magnetic shielding is achieved by, I have already discussed this also. So, tell me, students, very good, concentrating magnetic field lines. The unit of magnetic flux is Tesla, Joule, Weber, Ampere. The unit of magnetic flux is tell me, students, some more 5 questions we have. Very good, Weber. Which statement about diamagnetic materials is correct? They are strongly attracted to magnets, they have unpaired electrons, they weakly repel magnetic fields, they form permanent magnets. So, tell me, students, which statement about diamagnetic magnetic materials is correct? So, what is the answer for this question? Read the question properly. Yes, very good, students. They weakly repel magnetic fields. Match the following pairs and identify the incorrectly paired. Iron, ferromagnetic, copper, diamagnetic, aluminium, ferromagnetic, chromium, antiferromagnetic. So, who is going to identify the wrong pair and mention that wrong pair in the in your comment section, and even mention aluminium is which type of magnet. Very good. Aluminium is, it is a paramagnetic material. Okay, aluminium is paramagnetic material. Very good. Next, identify the incorrectly paired statement. Like poles repel, law of magnets, ferrites, ferrimagnetism, wood, magnetic material, nickel, ferromagnetic. So, identify the incorrect pair. Yes, very good, students. So listen, if you know the concept, so how many questions you are attempting, okay? Because, okay, by this you must know that we have to read the concept first, okay? If we read the concept, we can automatically like answer any type of questions. Either it may be a match the following or maybe statement wise question or assertion reason questions also, okay? Very good. So wood, it is not a magnetic material, it is a non-magnetic material. Which of the following statements is incorrect? Magnetic poles always exist in pair. Magnetic field is strongest at the center. Unlike poles attract each other, a magnet has a magnetic field around it. So among these four statements, one statement is not correct. Identify and tell me the correct thing in that incorrect statement. Yes. Why? Because magnetic field is stronger at the pole and weaker at the center. Okay, very good students. Match the following and choose the wrong pair. So this is very important. Okay, magnetic flux, Weber, magnetic moment, Joule per Tesla, magnetic shielding, plastic sheet, compass, directive property. So tell me students, identify the incorrect pair and mention the correct thing in that place. Very good students, very good. And in the tomorrow morning session, I am going to discuss about classification of elements and periodic table properties. Okay, in chemistry point of view, at sharp 11 o'clock, I am coming with like a classification of elements and periodic table properties, and today in the evening session I am going to discuss like a Bhakti and Sufi movements in Indian history point of view. So I am going to discuss Bhakti movement and Sufi movement. Okay, very good students. Magnetic shielding, why? Because for magnetic shielding we will not use like plastic materials, we will use the materials which is having the strongest magnetic properties. Tomorrow is Sunday, okay, sorry, okay. Next, so Sankranti offers are going on students, up to 60% offers are going on. So each and every students utilize this opportunity. Today is the last date to grab these offers. Any course you can get it only for $499. SSC exams complete course are also available on our app. Railway exams are also available on offers. Bank exams are also available on offers. Bank SSC RRB combo courses are also available on offers. Up to 60% offers are going on. Today is the last date to grab this opportunity. Okay. APPSC, SI and Constable courses are also on offers. Zero to Hero course. So this is also having an offer up to 60% offer. Okay. So each and every course you are having the classes both in English as well as Telugu languages. Okay. So we are having Telegram, Instagram and WhatsApp channels. Please join in those three like channels so that you can get daily current affairs PDF. And not only that, so daily we are conducting live classes in Chandan Loik's Telugu, Chandan Loik's English and Chandan Loik's main channel. Please subscribe to those three channels so that if there is any live session you will get a notification. Okay, that's all for today. Let's meet in the evening session. Chandan Loik's Telugu YouTube channel. Okay, Bhakti and Sufi movement, Indian history. Bye students, take care.